Today I'll be taking you through my biomimicry presentation. I just looked up at a few different ones that I want to give examples of, but first I do want to define the term. So literally biomimicry means life imitating. So bio is life, mimic is to imitate. And so this is when we are actually taking a natural phenomena, whether it's a tree, whether it's a humpback whale jumping out of the ocean, and utilizing some sort of technique that has evolved in those species to hopefully aid us as humans in different technological endeavors. And the primary thing that the speaker talked about was to solve design problems. So one of the biggest design problems that I'll be talking about is energy crisis, the energy crisis in the world, and how we can kind of combat that and how that in turn helps the ecosystem. So from biomimicry.org, aptly named, there were three cool ones that I thought were really sweet, so I decided to put them on here. One was the Sharkskin Speedos. Turns out in the Olympics in 2008 or 12, this was a brand new thing of this like moisture wicking, like hydrodynamic material that was very similar to shark skin. And it turns out that like 98% of those who medaled at the Olympic meet were wearing Sharkskin Speedos. Now that may be because it was very big at the time, and so literally everybody was wearing them, or everybody who was wearing them did incredibly well. So that was cool. Another one was wind and water turbines, inspired by the humpback whale ridge that's on the edge of their fins, that actually increases lift, specifically in when they're jumping out of the water, as well as in wind turbines, and reducing drag, which is more important in water turbines. And then finally, moisture wicking paint. I was fascinated by this one in the lecture. It's very similar to the lily pad that actually wicks water droplets off of the top of them. So it's very similar, but on the walls of a house. So if it rains, the water actually just rides right down the house into the sewer drain, and there's no oxidation, there's no dirt accumulation. It's pretty sweet. So I mentioned the energy crisis. So my design that I thought of and then promptly looked it up, and it already existed, was the sun following solar panel. Now this could be programmed pretty easily, but in sunflowers it is more genetically programmed, where the sunflowers actually turn depending on where the sun is on the horizon, so it can maximize its photosynthetic levels, which I just thought was fascinating. So therefore with solar panels, if you have a solar panel, full on straight light hitting the panels, it can turn and get that direct sunlight that entire time, whereas if you have, say, it facing over here and the sunlight's coming here, but then the sun's over here, well, now we're losing out on a bunch of potential sunlight. So obviously if it follows it, it would be much better. Most of them do this, which is really sweet. And upon research of these solar panels, I thought, well, it's becoming to be a bigger industry, but it's not the big industry. And I think that's due to the constraints of the model itself. For example, the solar panels have to be within a specific temperature to optimally function. So there has to be a lot of cooling mechanisms, which takes energy. And then also there's a very small circuit. So the way it's built is there's like a sandwich of a positive metal and then a negative metal, and I believe that's boron. And as the light hits it, it excites electrons in the metal that actually escape and then run through, or I mean the photons excite it, so then the electrons can flow through, creating an electrical current, thus producing energy through a lot of other cycles. Well, if we can somehow increase the optimal functioning capacity of the solar panel, my designs may work a little more. So my first design was obviously following it. It had already existed, so I took a next step. With magnifying glasses, they're opposite of our corneas. The corneas direct light to a specific point in our eye so that we can see. Convex lenses actually scatter and amplify the light. So I'm wondering if those sort of convex lenses, if you put one over each panel, would it increase the light absorption? Perhaps. It would have to be optimized, like I said earlier, but that's also similar to biomimicry, taking lenses and folding them and shaping them just like my contacts are. And then also, I drew a little model over here. I can move my head, but light is hitting these solar panels, and it's actually reflecting a little bit because we can't absorb literally every single ounce of light. Otherwise, the solar panel would have to be black, and that also creates design challenges. And so when it hits it, it's reflecting some. Well, what if we could actually target them so that when they reflect, they actually go to the other solar panel? So if they're set like this, would it optimize it? It's worth some shots. But this is seen primarily, I was looking up in polar bears, but it was more about heat radiation, where the skin and the hair of the polar bear, it's trapping radiation, and the radiation comes out of the skin, obviously, but then it bounces off the hairs in such a way that it absorbs pretty much all of the heat. So they're actually, you can't detect them with infrared light because it's absorbing all of that infrared radiation back into their bodies. So they're completely insulated, which is fascinating. So that's kind of what I was getting at with the whole reflectivity thing, where we're playing with angles, and so it directs it to where we need it to go. Might work, might not. And so then taking that and extending it to the ecosystem, this could be a direct benefit. We'll reduce fossil fuel burning, which increases methane and CO2 gas in the atmosphere. If we reduce that, obviously less greenhouse gases to effectively promote global warming, which we don't want. And we will also be less reliant on those types of unsustainable sources like fracking. I know that in Pennsylvania, I forget which county it was in, but they were fracking, and it turns out that those little methane and different pollutants were getting into the water system, and specifically the methane was at such a level that it could be deemed hazardous to the general population. So there's a big uproar about that. So we wouldn't have to rely so much on fracking, which would be great for natural gas reduction. And then also energy farms. I know this from Iowa. A lot of our corn is actually being produced for ethanol, which is in a lot of our gas tanks, which, I mean, it says, oh, cleaner energy for Iowa, which it does burn a little cleaner. However, we are also utilizing a lot of space to do this sort of thing to give us energy for our cars, when we could be directly taking that energy from the food and, giving it to people. So we would decrease the amount of farms that we need for producing ethanol, which would thereby decrease nitrates in the leaching systems, and therefore hopefully help keep our runoff into our rivers and streams a little more free of nitrates and the sort. So that is my presentation for today. Hope you enjoyed it, and thank you so much. We got 1 week left. It's been a pleasure.